Welcome to this video. Uh, this is a series on the lead code by Serans Parhad. Sorry, I didn't get the pronunciation. Shyam Prashad. It has the different algorithms, 180 on different topics, different level of difficulties, and I'll be going through them. Currently, we're on the number 5, which is the climbing stairs. If you like this kind of videos, I encourage us to like, share, and subscribe. So let's go to this video. So climbing stairs. So the algorithm says you are given a staircase. It takes n steps to reach the top. Each time you can either take 1 or 2 steps. And the question is, in how many distinct ways can you climb to the top? In how many distinct ways can we climb to the top? So, for example, if we have n of 2, there are 2 steps. How many times? So they say the answer is going to be 2. So let's just try and. So we have n is 2. So let's say we have, this is our staircase. So we have stair 1 and stair 2. So, and we can either only take either 1 step or 2 steps. Only take 1 or 2 steps. So it means if I'm starting from here, I could take 1 step, that's one approach, or I could take 2 steps at once. So that's why the total number of ways is 2. There are 2 ways I can do this. I have a video where I've actually explained this extensively. I explained the thought process and why I did it. I used about 3 videos trying to solve this algorithm with different approaches and showing the thought process behind it. I will put a link to that in the description. Please, I would like us, if this is not clear enough, to go and watch those for a clearer understanding. So I won't be going too in depth into this. So here we have this as the number of ways. So for example, if we have a staircase that was, let's say we had 1, 2, 3. Let's say we had 3 stairs. So it means we have that the first, we could either go 1, 1, and 1. We could go 1 and 2, or we could go, we could go 2. We could also go 2 and then 1. So there are 3 ways you can do this actually. So if we continue, we will see that it follows a particular pattern. If there is 1 stair, there is 1 way. If there is 2 stairs, there's 2 ways. 3 stairs is 5, is 3, sorry. 4 steps will be 5, 5 will be 8, 13, 21, and this follows the Fibonacci sequence. So we could use the Fibonacci sequence to actually solve this question, and that's what we'll be using. And the other approach I use, we could watch that video to see an explanation on how it is being utilized, but I will just go with this simpler approach to solve this particular algorithm today. So let's get to our board and see how it looks like. So Fibonacci series is just, maybe I showed that on the board. So for Fibonacci series is a summation. For example, you see when we are 3, 3 is the sum of 1 and 2. 5 is the sum of 3 and 2. 8 is the sum of 3 and 5. 13 is the sum of 5 and 8, while 21 is the sum of 18 and 8, and so forth, so forth. So it means the sum of the previous 2 is what will give us a Fibonacci series. So basically, based on that, I will just use recursion to solve this. So let's say we have public, let's just have an int, because we want to return an int, and then we just have a climb steps recursion, and then we just have the number of steps we need to take. So we could have here that we know that, so if the number of stairs is 1, or we know it's going to be 1, so we could just say we return climb course, and then we give it, because we know is the equivalent of adding that of the previous 2. So and then here we just have return and then pass in. This will solve it for us. So if we run this and because we're using recursion, so you see it passed all these test cases, but it will fail. So let me just try and change the parameters. There should be somewhere where I can change. Yes, okay. So let's say I want to use, because I think yes, we could use up to 45. So let's say we have a 45 here. I think we have an issue here because of time. Yes, I think we have an issue. If you watch that video as I said, you will see why the time is not sufficient enough, why we're having this time limit exceeded. So what we just need to do is we need to memorize this. We call it memorization. So to do that, okay, I will just need to have like a dictionary. So let's just call it. So I need a dictionary, and okay, because the value is going to be an integer. So I have, let's say, dictionary. Let's just call it dictionary. And so what I will just do is also, if my dictionary, if it contains the key to n, then I just return what is in the dictionary for n. And also here, I also want to store this value somewhere first, so that I could then say, let me just shift this a little so that it could be in one line. So, and then I could just put this in the dictionary first before I go ahead to, and then and result, and then I could return result, so that we can have, so memorization is just a way of keeping track of what we've done before, so that we don't do it again. So if you look at that video, as I said again, it will explain why this memorization is important and what it fixes. Yeah, so just pass in our dictionary here. I'll pass in the dictionary here again. And let's try. Okay, so we need to pass in the dictionary. So let's just pass in a new dictionary of type int. Okay, and let's run this again. Let's see. So you see, for n of 45, we actually have an output and it's successful. So what we just did here was memorization. So if we submit this, we'll get, let's see, there's no issue. Yes, there was no issue, and we have our solution here. So basically here we just use recursion, basically the Fibonacci series, to solve this particular algorithm. If you still not clear, I really encourage us to go back and watch the video I dropped in the description. It's going to really clarify why and how it helps. We went with the way we did it here. If you like this kind of videos, I encourage you to like, subscribe, and share the video. Thank you.